Hello, my name is Kartik Pontula, roll number 20CS10031, and in this video I'll be showing my second DIY project which I simulated in Tinkercad circuits. So I've thought of making a fan that would change its speed according to the temperature of the room. I thought it'd be convenient if the fan would move faster if the room gets hotter, and if the room gets colder, the fan would move a little slow. So without me having to manually control the speed of the fan with a regulator or something. So I implemented that as follows. This DC motor represents the fan, which is whose speed will be controlled by the temperature sensor. This one, the TMP36. The DC motor is driven by the L293T motor driver. And in case the user doesn't want the automatic temperature control, he can manually set the control with one of these three buttons as well. This would set it to a low speed, a medium speed, a high speed. This switch would switch between manual modes and automatic mode. Right now it's in manual, and if I flick it, it will change the speed only based on the temperature and won't have control even by pressing these buttons. And this is an RGB LED that shows a particular color depending on what the temperature is. Now instead of showing the temperature to be instead of having the fan speed vary directly proportional to the temperature or something, I have decided to make it this way, that the fan would have three possible speeds. Depending on whether the temperature lies in a certain range, it's above that range or below that range. Now for the circuit setup, this is the breadboard, and we can see that this positive rail is maintained at 5 volts. This positive rail is maintained at 9 volts by a DC source, and these two negative rails are at the common ground. Now let us analyze the inputs that are given to the Arduino. What inputs would it require? It obviously require the temperature data, which is fed as an analog voltage from the sensor. It would also require the data from this to detect whether it's manual mode or automatic mode. And if it's manual, it will need to know from the user what mode it wants. So these buttons can be pressed by the user to switch the fan speed. Now the outputs given by the Arduino are as follows. It would obviously need to change the motor speed itself. So these three wires over here, they feed signals to this motor driver, which in turn will change the speed of the motor, and it will also feed the corresponding color to the RGB LED to indicate whatever color or the temperature of the room or what the fan speed is. It's going to show one out of three colors. Now I think it's time to show the code of this. I have specified the lower temperature to be 25 and the upper to be 36. If the temperature is in between them, it's going to have a moderate speed. The fan will have a moderate speed. If it's below, it's considered as low temperature. Above this, it's considered high temperature. I've set the speed values, that is to say the digital input that's coming from the Arduino to the motor driver through this aqua colored wire. This aqua colored wire is connected at, it will be connected, it's connected at pin number 11. So that wire is a pulse width modulated signal that's basically giving a measure of how fast the motor should move. And actually, let me open up the data sheet for the motor driver. This is the data sheet for the motor driver. And now we can see that for powering just one motor, we need to connect the pins from 1 to 7 and the pin 16. Actually pins 1 to 8 and pin 16. This is the 5 volts from the Arduino, the voltage from the battery, the 9 volts battery. This is the pulse width modulated signal that decides the speed of the rotation. It's a signal having values from 0 to 255. These two are values that decide the direction of rotation. If one is high and the other is low, it will spin one way. Vice versa, it will spin the other way. These two are outputs coming from the driver to the motor. These two are ground. Hence, each and every time we have to specify one of these wires to have a high signal and the other one to have a low signal. I have fixed them to have such that one of them has a high signal, the other one has a low signal. We can see they're connected at ports 9 and 10, pins D9 and D10. So as a result, because of this, I have taken pin 9 to be high, pin 10 to be low. That's to decide the orientation of the fan. Now I've read the analog pin A3. We can see that A3 is the signal coming from the sensor. It's an analog signal from 0 to 1023 that is stored in temp analog variable. I convert this temp analog variable to the Celsius temperature according to this linear map. Now, how do I know the variation of this? How do I know which voltage, which analog value corresponds to which temperature? I'm going to pull up the data sheet of the temperature sensor itself. Right, so this is TMP36, this line B, and from this graph, it has also been given in the datasheet itself that at 25 degrees Celsius, the output voltage would be 750 millivolts, and it's also been given that the slope of this line is 10 millivolts per degree Celsius. So from that we can directly find the linear relation between the voltage and the temperature, and we know how to convert the voltage to an analog signal. It's just the analog signal by 1023 is equal to the voltage divided by 5000 millivolts. Using this, we can estimate what would be the theoretical temperatures at analog signal 0 and analog signal 1023. These temperatures won't be ever attained and the sensor won't work at these temperatures, but theoretically, by finding out the right equations, we can say that 0 is mapped to minus 50 degrees Celsius and 1023 is mapped to 450 degrees Celsius, and it actually becomes evident from the code. We can see here that the mapping of this value is such that it was from 0 to 1023 and it now mapped to this. That value is stored in temp C. This value is stored in temp C. Now, obviously we'd have to know which mode this is being operated in, whether it's in manual mode or it's in automatic mode, the temperature control mode. In this, if the switch is in this configuration, we see that this signal is going to be low because the brown wire is grounded. So in a low signal, we have taken it to be manual control, and for a high signal, we've taken it to be automatic. And that signal we can see is the orange wire that goes to analog pin A4. So we have two if conditions. If the analog pin A4 is 0, meaning that it's manual, do something, and if it's 1, meaning that it's temperature control, do something else. So in this case, when it's manual, we are not going to take the data from the sensor. The only data we will take are from these buttons. Now the circuit that I've connected works as follows. Every time I press one of the buttons, say this button over here, this wire is going to have a high signal because this is connected to 5 volts, and when I press it, this will have the same 5 volts. So every time I press a wire, there's going to be a high signal transmitted to either A0, A1 or A2, and depending on which one becomes high at a certain instant, the Arduino is going to decide what color this LED will be and what fan speed it will have. Now let's look at it in detail. With the manual mode, we can see the pin A0, that as you can see it corresponds to the input from the first button. If whenever that becomes high, because this loop is running repeatedly a lot of times every second, so whenever it becomes high, do the following: set the RGB LED to be a light blue color, meaning it's a relatively cold temperature, and change the fan speed to low speed. I have set the pin 11, which is this over here, to be the corresponding analog value, and 3, 5 and 6 are where this RGB is connected to the Arduino. And we can see here, this is 3, 5 and 6, RGB in that order. So that is if the user presses the button corresponding to low speed. But if they want medium speed, this will be executed. So it means that the pin A1 will have a high signal, the pin A1. So then the bulb color would be set to a green, and the fan speed would be medium. And if the user presses this button when they want a high speed, the corresponding values will be given. It will be a red color and it will be high speed. That is for manual mode. Now when I flick this switch, it will be in on position. That's when it will take inputs from this temperature sensor to decide the fan speed and the RGB LED color. And here's how it's decided. If the temperature C is less than lower, which was set to be 25, then you set it to light blue, low speed fan. If the temperature is between greater than equal to 25 and less than 36, set the bulb green, medium, and the fan speed to be medium. If it's a high temperature, set to be red colored and set this to be a high speed fan. So, and then the user can switch this anytime, and accordingly the Arduino will know whether to read from one of these inputs or to read from this input. So that's the code implemented in blocks. I'm going to run the simulation once. So right now we see it's not doing anything because, well, it's set in manual mode, and we actually, none of these signals are high, so none of the if statements are actually executed. It's just waiting for us to enter something. You can see 0 RPM. If I press this, we can see it has around 6500 RPM, and the bulb is going blue, meaning it's moderately cold. The temperature is less than 25. I mean, we have set it to be low speed manually. And then when I press this, it becomes green, the RPM goes up a little bit. And when I press this button, it becomes red, and this is the highest speed that the motor can attain. So this color gives a measure of what the speed is and not really the temperature. Now for the actual purpose of this project, when I switch this, it's going to go into automatic mode. It's going to decide the fan speed based on the temperature, and I can control the temperature manually like this. We can see that right now it's 25 degrees Celsius, so it's a blue LED and a low speed. If I go a little higher, oh, let me go, okay. If I go to 30, it becomes green, and about 11, about same as medium, and a little higher, then the temperature is quite high, so the fan will move faster. That's the circuit. And then we can, and then when we don't want the temperature control, then we can just get back manual control by pressing these buttons. And to note, when it is in temperature control mode, we cannot press these buttons. It won't do anything. So that's the simulation. Now I'm going to look at the textual code, which is been written over here. I'm going to copy it, and I'm going to paste this code into the Arduino IDE. And I can save this here, and it compiles the sketch successfully, and we see it doesn't occupy more memory than it should. So yes, this circuit, when done, when created with the appropriate connections, and this code, when it is uploaded into the Arduino, we can bring this project to life. Thank you for watching.